Greetings, everyone. At the beginning, I'd like to thank the organizing committee of Future Neurology 2023 for inviting me to give this talk in this conference. Today, we are going to talk about neurocriminology and artificial intelligence, neuroprediction. I'm Ghadeer Abdelaal, Forensic Medicine and Toxicology Senior Lecturer at Faculty of Medicine, 𝐍𝐞𝐮𝐫𝐤 University, Fellow of the Egyptian Forensic Medicine Authority, founding member of 𝐍𝐞𝐻 Forensic and Clinical Toxicology Research Laboratory, also a founding member of the Save Women Clinic in 𝐍𝐞𝐻 University Hospitals. Have you ever imagined a world where law enforcement can predict a crime before it even happens? Or can artificial intelligence help us read and unlock the mysteries of criminal minds? Thanks to the advances in neurocriminology and artificial intelligence neuroprediction, these fictions are about to come true. Cesare Lombroso is an Italian physician who is considered the father of criminology. He did research and wrote on different topics such as mental diseases, methods to study corpses, and brain pathology, but he is the best known for his book, The Criminal Man. Lombroso believed that criminals were born, not made, and developed his theory of criminal anthropology. The Criminal Man was first published in 1876. And according to Lombroso's theory, born criminals differ from normal people due to certain physical abnormalities he referred to as atavism or atavistic characteristics. He believes that criminals have characteristics from primitive humans. Thus, he derived the name from the Latin word atavus, which means ancestor. Lombroso believed that criminals could be identified by certain features such as asymmetric face, sloping forehead, large jaw, long arms, and epilepsy. Although Lombroso's work was controversial, it helped to focus attention on the role of the brain and genes in criminal behavior. Neurocriminology is a relatively new field of study that combines the principles of neuroscience and the criminology to understand the biological basis of criminal behavior. Recent advances in neuroimaging have made it possible to study the brain in unprecedented detail and understand the neural correlates of criminal behavior. With this understanding, neurocriminologists are able to develop more effective approaches to rehabilitate criminals, develop new treatments, and develop prevention strategies to prevent future crimes. These are some examples of the advanced neuroimaging techniques. Many factors contribute to criminal behavior, such as biological and environmental factors. Let's begin with biological factors. Brain injuries and brain disorders, either structural or functional disorders, especially in prefrontal cortex and amygdala. In addition, certain genetic variants associated with impulsivity and aggression, such as monoamine oxidase A genetic variants and dopamine receptor D4 genetic variants. Also, there are some hormones associated with aggressive antisocial behavior, such as high level of testosterone or low level of cortisol in response to stress. Brain chemistry alterations also associated with high psychopathy scores. For example, low levels of serotonin and hypersensitivity of dopamine reward system found more 4 times more than in normal individuals. And the most reliable one is the ratio between the metabolite of dopamine, which is HV8, to the ratio of the metabolite of serotonin. Neurocriminology research mainly focused on the neuromarkers of personality disorders with persistent antisocial conduct. For example, antisocial personality disorder and psychopathy, as they are the most correlated with high rates of recidivism and reoffending. These disorders share many traits as behavioral disinhibition and lack of empathy that are thought to have common neurological bases. For example, dysfunction in the prefrontal cortex and amygdala. The prefrontal cortex is responsible for regulating behavior and decision making. Its impairment results in disinhibition and impulsivity, while the amygdala is responsible for processing emotions, particularly fear and aggression. Its dysfunction can lead to a lack of empathy and difficulty in processing emotions related to fear and aggression. The neuroscientist Adrian Raine, who is the author of The Anatomy of Violence, studied the brain of a murderer using positron emission tomography scan and compared it to brains of normal controls. The positron emission tomography scans of the murderer revealed a relatively low glucose metabolism in the front of his brain, which explained his impulsivity and violence. This example discussing the structural disorders in the frontal lobe, not only functional, but here is a structural tumor present in the frontal lobe. The MRI scan of a man who was sentenced to 1 year in prison charged with sexual pedophilic behavior was brought to the neurosurgery department following a series of epileptic fits. This MRI scan shows a large tumor of the left frontal lobe. Actually, this was the cause of his sudden pedophilic behavior. There are some environmental factors that contribute to criminal behavior, such as prenatal exposure to toxins like alcohol, nicotine, and lead. Then child abuse, from physical to sexual and even neglect. Social problems such as family troubles, school failures, and addiction. And poverty due to financial troubles and unemployment. Artificial intelligence and neuroprediction is one of the most promising areas of neurocriminology. They use machine learning algorithms to analyze brain data, either structural or functional neuromarkers, and to predict risk of future criminal behavior. Multi-voxel pattern analysis is the application of statistical machine learning algorithms to neuroimaging data. Unlike the traditional univariate methods that analyze only one site at a time, it allows for the identification of spatial and temporal patterns in the data. The MVPA has been used to decode visual features or the intention to execute one task over another. Also, the sequence of task preparation and even lie detection. This is an example of brain reading. This is one of the application of the MVPA that uses patterns of brain activity to make a reverse inference and decide what subjects are looking at or thinking about. The presented image to the subjects are the red boxes on the top row, while the images reconstructed from the functional MRI signals are the gray boxes at the bottom row. So the upper row shows the actual pictures that the person have seen, and the reconstructed images are the bottom row. Here we can say that we are at the era of mind reading. Artificial neuroprediction of recidivism and risk of reoffending was studied by Aroni 2013 using AI prediction models coupled with functional MRI. They concluded that low anterior cingulate activity, which is a brain region associated with impulse control and error processing, can be a potential neurocognitive biomarker for persistent criminal behavior. Despite neurocriminology and AI neuroprediction benefits, there are some ethical concerns, especially the invasion of brain privacy and thought privacy, as it uses personal data to make predictions. Then biased results can occur as AI machines may learn from biased data sets, which could impact the accuracy of their predictions. In addition to the discrimination, possibility of being used to profile individuals based on their characteristics and traits. Finally, fairness and justice, particularly in terms of a potential wrongful convictions depending on these new techniques. Neurorights first emerged in 2017, and then in 6th of October 2022, the United Nations resolution on neurotechnology and human rights was adopted by the Human Rights Council at its 51st session. The resolution particularly focused on the right to privacy, the right to non-discrimination, and the right to be free from torture and other inhuman treatment or punishment. To sum up, neurocriminology and AI neuroprediction tools have the potential to revolutionize the criminal justice system. However, ethical regulations for their application and further research are needed to validate their findings. Thank you.